Hello, everyone. This will be a talk about really old technology, in IT terms, I mean, about Oracle Forms. How many of you seen this technology in action by using it, by developing it? A few people. Okay. For the rest of you, I hope that I will be able to show some techniques that will be useful to better build tooling for somehow weird kind of systems. So, a few words about me. My official name is Bálint Varga-Perke, but most of you may know me as Buherátor. I'm a co-founder of Silent Signal, which is a company focused basically on penetration testing, so that's what we do. And it's nice because we come across technologies like Oracle Forms and other animals, which give us new interesting targets. I'm a long-time activity supporter. Until last year, I was part of the program committee also, but not anymore. And I have to say that I'm really happy to see how nice this new edition is turning out. So thank you for the organizers. About Oracle Forms, this is the official definition or introduction by Oracle itself. Oracle Forms, a component of Oracle Fusion Middleware, is Oracle's long-established technology to design and build enterprise applications quickly and efficiently. So, who uses this technology, you may ask? Well, I encountered it at several banks across Europe, so large financial institutions. And there is this story. I'm not really good at bureaucracy and filling out papers and everything. So I did something wrong. So I was invited to one of the Hungarian government offices to sort things out. And the clerk lady was turning her monitor towards me with all my data and records and everything on it. And it was in Oracle Forms. So it's used at pretty important places, so to say. So let's look at a bit of the history. When you open the Wikipedia page, you will see a nice little table that tells you that the first predecessor of Oracle was released for Oracle database version 2. Now we are at 12, of course, and version 2 was the first version of Oracle, because Larry Ellison, so the guy, the chief of Oracle, figured that nobody would buy version 1 of a software, so they first released version 2, obviously. And it happened in 1979, so I wasn't even born yet. In 1985, I still wasn't born, they developed it to SQL Forms, and then it was about around 1996 and 1997 when the World Wide Web happened. So all these origins were before the web was even invented. But with the Oracle Forms version 6 released for the Oracle database version 8, it was a web forms-based, HTTP-based version of the product. We are dealing with today the products below the green line, so starting from 10G. I encountered the versions based on 10G and 11G. I haven't seen 12C yet, but I assume it would be really similar to what we will see. So to have an idea about what this long history creates as a problem at the technological level, here is the error code, this FRM92 whatever, that everyone will probably face when he or she first installs or tries to install Oracle Forms or an Oracle Forms-based application. It says Oracle JInitiator version 2 low. Well, as it turns out, this error message has nothing to do with the real cause of the error, so you can play with JInitiator on your installation, but it won't help. What does help is bracketed in green, is that you have to set an environment variable that tells Java that it's still produced by some microsystems. And then everything works. Don't ask me why. So, some previous work. I'm not sure how to pronounce his name, but I think it's Hoshan. He presented research about the Oracle e-business suite called Hack-Proofing Oracle Financials, in which Oracle Forms is also used. So if you're using e-business suite, then you are using Oracle Forms. This research focuses on the framework itself, and he did find some quite interesting vulnerabilities. And I myself wrote a paper for the SENS Institute called Automated Security Testing of Oracle Forms Applications, in which I try to present tools and techniques to test the applications itself that were implemented inside of this framework. Everything is available on GitHub, but as it turns out, my first attempt, this attempt, wasn't really good. So now I will present you the original problems, the original solutions, why they were wrong, and how they could be made better. And I could also show you some new improvements that happened like a couple of days ago. So here's the protocol overview. Oracle Forms works like a Java applet-based application. So you open a web page. I show you a small demo of that. So this is Windows 2003 because, you know. So here it is. This is Oracle Forms. It's loaded by Internet Explorer. Here is a custom window. This is what the programmer did, the developer did. You can just type in some text. It looks like a bunch of database records, right? And Oracle Forms does some work for you by generating code that automatically updates the database, for example. So if I say, okay, field 1 must be whatever. Can you read the text and everything? Okay. So, and I click Save. This whole line is generated by the framework itself, so it's not done by the developer. It's internationalized, and it has all the basic functionality that you expect when you're interacting with a database. You can query records, save records, update records, etc. And here we can see that, okay, this whatever, so this new thing is now inserted into the database. In practice, the developer has to do some coding like this. This is another piece of code which I will show you later. And Oracle Forms was based on an idea called rapid application development. So this is like Delphi or Visual Basic. You just draw the window you want to present to the user, and then define some event handlers, like when button pressed event handler, and this is some PL SQL code. But how do we communicate with the server? This is the client. This is the Java applet that runs on the client side. How do we communicate with the server? The communication can be done either on TCP or TCP HTTP. Most installations that I saw use HTTP. So the headers and everything are like you're dealing with a standard web application, but it's of course not a standard web application. The payload is encrypted, so when we go here, hopefully we will see that, oh, sorry. That's my politically correct background image, by the way. So here are some responses from the server. Here's a bigger one. As you can see, it's total gibberish. So there are no readable strings or anything in it. And this is how the framework communicates with the server. About the encryption, Oracle states that it's not as strong as the SSL standard. Thanks. HTTPS is supported, but it's a pain in the ass to configure, so no one uses it. Inside the encryption, as we will see, there is a custom data serialization format that we will discuss. And most importantly, the whole framework is an event-driven framework. What does that mean? So when you're dealing with a web application, the workflow or a flow of information looks like, OK, the user selected this ID, like he brought a new cat or whatever. The ID is 1337. And then the server parses the request and generates a response and pushes the full response for the client to render in the browser, right? If the state is stored at server side, so if we are talking about an event-driven application, then the server sees that, OK, there was a click at this coordinate. There was a list choice from the list 3, and the user choose the second list item, and then left-clicked at the coordinates this and this. You have to realize that in this case, the server has to know all the details about how the user interface looks like. So a whole bunch of state information is stored at server side, and this makes, as we will see, testing really hard. Why is that? First of all, you cannot do parameter manipulation because you can manipulate parameters, of course, but they will have no effect because the parameters you see, the identifiers you see, are not the global generic identifiers, but only valid locally, for your session only, for that time only. And as for example, the user interface changes, so you navigate to another window, open something up, close something, the actions that were valid before become invalid. So you cannot just run a scanner from Burp or whatever tool you wish to use. We will use Burp at the end. Because it will mess up the state and will do basically nothing at the server side. This is very similar to, for example, Java servlet faces. Have you encountered Java servlet faces based application testing? Raise your hands, please. Not too many people, not too many. So for those who didn't do that, it looks like, OK, I want to send in a parameter, but when sending the parameter, the UI changes. So I don't only have to send one request to the server, like this is the new parameter value that I want you to parse, but also have to send several other custom requests to move the user interface state at the server side back to the original form so you can feed another new parameter, a new test case into the application. And this is what happens with Oracle Forms also. Let's talk about serialization. Serialization is binary, so you cannot really read it. You can figure out some ASCII parts in it, but otherwise you don't really know what's going on without looking at the implementation. They are variable string lengths, and the serialization can contain recursive messages. So what you see in the message body here, for example, like this is called a message. And this message has properties which hold objects, which can be messages, which can hold properties that objects, etc., etc. This is, OK, and one more thing about strings. So if you send, for example, a string object from the client to the server, or vice versa, you never, not always have to send a real string like an ASCII byte sequence. But you can back reference previous strings. So for example, if I sent in admin once and I want to send admin again, then I can just back reference the previous request because server and client caches strings. Here's how the encoding look like. It's not that important. You only have to see that you basically have some byte sequences, then the actual value, then some header, again, then the value, then the header, then the value. So, unfortunately, this format is not trivial. I tried to re-implement it in Python and Java, but didn't really succeed, based on the decompiled code, of course. I also tried to generate code for parsing these structures using kitestruct, which is an awesome tool. Unfortunately, it was designed for same formats, not like this. So I didn't succeed. I don't say that it's impossible, but it's hard, much harder than just reusing the code that's already there because it's Java. So the code for message parsing is in the oracle.forms.engine.message class in the read details and write details method. And this class can be found in the frmall.jar file. Remember that name because we will use it a lot. So you can just download this jar and interface basically with this message class to deserialize and reserialize messages for Java objects. Encryption. So the encryption algorithm is on the slide. Anyone recognizes it? No one? It's RC4. It's not as strong as the SSL standard, of course. It's implemented in the encrypted input stream and output stream classes. It's a standard implementation, so if you do a crypto in Python or C or whatever other language and compare the results, they will be the same, so that's nice. So how about breaking it? We know that RC4 is broken. Every auditor will tell you that. There are some known attacks like Bar Mitzvah and No More, which showed serious cryptographic attacks against the RC4 stream cipher. But unfortunately, we are not the NSA. So we are not usually smart enough, and we don't have the resources to collect 2 at the 23rd messages to do a brute force attack on the first, I don't know how many bits. So these attacks are not very useful for us. But still, we have to keep in mind that RC4 is just a standard stream cipher. And the stream cipher operates like putting out a key stream based on the key. This is the top box on the right-hand side. And you just XOR it with the plaintext to get the ciphertext. It's really easy. But if it's not implemented correctly, it can be attacked in several ways. So for example, in case of Oracle Forms, there are no integrity checks in place. So if you flip one bit in ciphertext in transit, the same bit will be flipped in the resulting plaintext after decryption. This is basic cryptanalysis. You can learn about it in the university. So it's not that interesting. There's also a non-plaintext attack. What you have to realize, and this is not in the paper, what you have to realize that there is not one key stream here, but 2. One at the server side, one at the client side. The key stream is this KS stream, and the streams with Q are requests and P are responses. So if you read the news, then you'll know that using the same key stream twice is a bad idea because you can basically just XOR things together to get the plaintext of a previously unknown piece of stream. What you need to know for this is part of one of the plaintexts, so it's a known plaintext attack. But this is very much the case because you know the message headers, for example, they are quite static. So by predicting the message headers in one stream, you can deduce bytes from the other stream. But it's still not good enough. We are forgetting about how this cipher is initialized. And this is where key exchange comes to picture. These are the main decompiled code parts of the key exchange mechanism. What it does is to send a fixed 4-byte string which is ASCII GDay, like good day, and then a 4-byte number, and the other party sends a static 4-byte string which reads mate, like good day, mate, and another 4-byte key part, and then it mixes it with the algorithm like this. So here we have 8 bytes exchanged, and they use basically 4 of them and dropping some bits. So it's obvious that it will be trivial to passively monitor and then decrypt any traffic. And also, if you cannot see the key exchange phase of the protocol, you can brute force it because the key is so short. So this encryption is basically no encryption. It's like transferring plain text. So if you are using Oracle Forms, please configure HTTPS. This is how the decrypted stream looks like in Burp. As you can see here, this can you see it? The letter sizes are right. Yeah, so you more or less can see that this is some human-readable parameter array or whatever, and you can read it. But there is a problem. So the next thing you want to do is to just tamper with the traffic and modify bytes and try out new parameters. The problem is that if you do that, then you generate extra bytes in the stream that is sent from the client to the server. So basically, the client will be desynchronized from the server because it doesn't know about that it should consume, like, say, 100 bits from its key stream. So when you do that, when you just randomly push in messages, the client just breaks and nothing will work again. We need perfect sync. We cannot just inject messages. We cannot delete messages. We cannot even have extra or missing bytes in our byte stream, so we can not really touch this thing because then things just break. So my first solution to this was a Burp plugin. Are you familiar with the Burp suite? Please raise your hands. Okay, most of the people are familiar with Burp Suite. So this is a Burp Suite extension written in Java. It directly uses the frml.jar that I showed you earlier to deserialize and reserialize messages. And it tries to do everything from encryption and serialization and stuff like that. It also registers insertion points for the scanner. So the scanner will know what pieces of bytes it should replace with like SQL injection tests and stuff like that. And it has a lookup table from which if you send something to the scanner, for example, the Burp plugin can know to which state it should reset the cipher to get the proper key stream that should be used to resend that part of the message again. This sounds complicated, and it is. So the client still gets desynchronized. Messages cannot be edited. You cannot use macros, which would be crucial to handle the event-driven approach that Oracle Forms presents. And quite frankly, on my GitHub, I got a couple of issues and questions about why it's not working, how can I use the scanner, and things like that. And I couldn't really answer these questions properly because I didn't have a cool answer either. Problems are hard to fix, hard to debug, and everything can break really easily. So how do we fix that? First idea was that what we need to do in the client to get it synchronized is to set the internal state buffer of the RC4 algorithm. Can we do this with a debugger? Theoretically, yes. Practically, not so much, because most debuggers are for integrated development environments, and they assume source code availability. You could use, of course, GDB, but it's not a real easy-to-use stuff. at least according to my experience. It's not really easy to write scripts for it, for example. So my other idea was that we could patch a debugger into the client. So a piece of code that receives messages from the attacker, from me, and accordingly sets the appropriate encryption buffers. So this didn't work either because it would require significant patching, and also when trying to implement the communications protocol with which I could set what the new state of the client should be, I faced that Java doesn't really have high-level communication primitives, so I either import some huge Apache library to handle like a message queue, or I have to implement everything myself, and the complexity grows and everything will break again. So that wasn't really nice. But what did work is that I figured that I could just strip the cryptography of the client altogether. So what will happen is that the client will send unencrypted messages, and I myself implement the cryptography that Oracle Forms implemented earlier, just after I modified the plaintext traffic in a way I wanted with an intermediate proxy. So at the implementation level, it looks like a Burp plugin that does reserialization and deserialization, and a middle proxy script that first of all serves a special FRML.jar to the client that doesn't have the crypto in it, and also does all the key exchange and encryption instead of the real client, so the server will see an encrypted stream that it actually expects. So how does it look like? Here I pose this virtual machine, and I show you another small demo program that I wrote. I restart everything because Java caches everything. Oh. Cancel, I'm sorry. So I will need to this, and I'm loading the extension to Burp, but I still have to patch the client. How do we do that? So first of all, here I have the demo. Here you can see this is the binary files, so the class files, the compiled class files of the original frml.jar that was provided by the server. And in this directory, there are the decompiled Java files generated by JDGUI, which is a really popular Java decompiler. And what I will do now is to just look up the encryption routines in the binary. They are in Oracle Forms Net. And here are these encrypted whatever classes. So I'm just copying the original source, the decompiled source, sorry, here, from the Oracle Forms Net directory. Now we have these Java files. And I'm looking for all XOR operations, the XOR operator. Here it is. So I just comment out this line. Because I don't want my plaintext to be XORed with anything. I do the same with the output stream. I'm looking for the XOR. Here we go. In this case, there are two methods who can do that. So we comment out both. And we try to compile these files, for example, the input stream first, it will not work. This is not demo effect. As you can see, there are some parsing errors at the line 71. The problem with decompilers is that they produce imperfect code. So if you want to do this recompilation with the whole project, then you will face like 3,000 such errors, which is impossible to handle. But here we only missed a small keyword, and now the input stream class can be compiled. And if I try to compile the output stream, it will fail again, but that's not so much of a problem because I can patch that also. Line 77, the same keyword is missing here. And now I have two classes which will do the stream encoding for me, but will not do the encryption, and that's the point. So what we can do now is to go back, have a copy of the original jar file, and so we can see this now more nicely. First of all, we have to delete all the digital signatures of Oracle because they will break if I change anything, but this can be done like this. After this, of course, the Java virtual machine, the client will complain that this is an unsigned jar. Will I open it? Of course I will, because I'm a pen tester. And here are the original classes, and I just add some new files to it. Yeah, I don't care about this. Demo, bin, Oracle, forms, net, and here we are. This is our encrypted input-output stream classes. Let's add, and as you can see, these are upgraded now. And now I can start my man-in-the-middle script, which will use this patched frmall.jar file to serve to the client. So I hope everything is in order. Oh yes, I also have to, so the client will now connect to Burp. Burp will connect to man-in-the-middle proxy, and man-in-the-middle proxy, who does all the encryption and stuff, will connect to the real server. So I set an upstream proxy here and see what happens in a minute. Yeah, this is the security warning I talked about. This is not good. I'm sorry, live demo gods are not with me. Just give me a sec. Oh, here we are. I'm sorry, I have to drink for this. So this is a very basic like login application. If I provide a username and the password here, like whatever, then it says invalid credentials, obviously. So what we can see here in the proxy history is that here's the response, like invalid credentials. Can you read it? Unfortunately, I have no idea how to increase the font size in Burp. I'm sorry about that. And here we can see the password that I provided, like this gibberish. What you have to realize that this was the request that contained the new parameter, and this was the request, this really short one, that contained that, okay, the user just clicked login. So this went through with different requests, and I got the answer for the second one. So what we will do, we will try to run an active scan on this. But first, we have to take care of the event-driven architecture of the application. So we go to project options and we record a new macro, a post request macro, because we want to issue another request after every request that the scanner sends out. This new request will be this last one, this short one with the E in it. Okay. Okay. The scope would be the scanner and repeater for now. And we should use the suite scope. Right. So, did I miss anything? Yeah, the scanner. The scanner should be configured like this. So, by default, burps try to figure out all kinds of insertion point by itself. But that's not a good approach because it will it will mess up the serialization format. So you have to untick all these fields. As you can see, I turned down the number of threads to 1 because we have only one cipher stream and only one message stream. Synchronous messages are not good. Scan speed is set to thorough and scan accuracy is minimize false negatives. And I'm also looking for SQL injections now. Most of these detections are mostly irrelevant in case of Java applications, so you cannot really do a reflected cross-site scripting in an applet. So for the demo, I only will look for SQL injections. I also start up Logger++ to see what's going on, and also start up this session tracer to see what's going on. And now, this was the, where are we? Here we go. So this was the original request that we want to fuzz, so to say. Here you can see a new tab that converts this serialized format into a standard HTTP query, and you can also edit this with repeater and in the proxy interception and whatnot, but that's not so important now. We just say that, okay, send this to active scan. And as we can see, it pushes out requests. Here they are. We can see the response length varies heavily, but that's not a problem for us because it means that we are doing a good job now. The scanner will find nothing, unfortunately. But if we, if we go back to our log, we can see eventually that, for example, here is an Oracle error message, which quite indicates that there is a SQL injection problem in here. But if we move forward, here we see a message called success. The request for this message was this short one, obviously, but the request before that was like this number, apostrophe or apostrophe number equals number. So this is a standard SQL injection sequence that triggered a login bypass. And it was found automatically, although Burp didn't realize it found it. So why is that? How much time do I have? Anyone has a clock? Oh, not so much. So, okay, 2 minutes. So, the thing that the output of the server, so the responses are serialized still, not encrypted anymore, but serialized. And that there is this string caching thing results in that Burp and other scanners cannot do really good heuristics about if they found something or if they didn't. So for example, in the previous example, burp tries to do the same trick again and expects to get a success answer again. But because success answer was already sent, the later response will only contain a back reference to that success string. So burp will see a completely different message for the very similar request, and it confuses it. So here are some pro tips. First of all, know your target. Know what you're targeting. Don't try to exploit impossible vulnerabilities like cross-site scripting in a Java applet. Focus on relevant weaknesses. And unfortunately, you have to still manually review scanner outputs. But the scans itself now can be done automatically, which is nice. Also, if you look at Oracle Forms technology, everything is written in PL/SQL. And PL/SQL is really easy to analyze. So if you are having a project targeting Oracle Forms and you can obtain the source codes, then please obtain the source codes and do a source code review, because SQL injections and things like that just fell out really easily. And do special care for authentication and authorization, because, as I said, most of the code is generated. So business rules like who should access which object from the database is usually not really handled properly. So thank you. This would be my talk. If you have any questions, and especially if you are dealing with Oracle Forms, testing Oracle Forms, operating Oracle Forms, please talk to me after the talk, because I'm really interested in your experiences. Thank you very much.